everyone. In this video, I'll be explaining how to perform Huffman coding given a set of symbols. Okay, the same concept can be extended to perform Huffman coding of an image. Okay, so let's get started. Okay, you may have a question like, why do we need to perform Huffman coding? Okay, so let's explain this with an example. Okay, in this example, I have taken a 4 cross 4 image. Okay, these are nothing but the gray values. Okay, I have assigned the symbol names for those gray values. So, okay, 123 is your symbol 3, 119 is your symbol 2, and 168 is your symbol 4, and 107 is your symbol 1. Okay, these are nothing but your symbols in an image, in an 4 cross 4 image. What happens in normal coding is you need to use 8 bits to encode this data. Okay, to encode 119 you need to use 8 bits. In the same way, 123 you need to use 8 bits. But in case of Huffman coding, what happens is you can encode this data in just 3 bits. Just 3 bits is enough to encode this data. We'll see how that is done. Okay, this is the advantage of using the Huffman coding. Okay, Huffman coding is used to achieve the compression. That means you need not use 8 bits to represent this data. You can represent this data without losing the information in just 3 bits. Okay, this is a lossless compression. Okay, and that's why we need Huffman coding. Okay, and the next thing is, this Huffman coding is a variable length code. That means it assigns more bits to the symbol which is not occurring frequently. Okay, and it assigns more number of bits to the symbol which is not occurring frequently, and it assigns less number of bits to the symbols which are occurring more frequently. S2 is the symbol which is occurring more frequently here, so it assigns less bits. That means 1 bits or 2 bits for this S2, and 123, it is not very frequent. Okay, in this 8 cross 8 array. That's why it assigns more bits, around 3 bits for this symbol. So this Huffman coding, it's a variable length code. Okay, now you have an idea what is this Huffman coding is, and let's go through the steps of the Huffman coding. Okay, what's the first step in Huffman coding? In Huffman coding, the first step is you need to find the probabilities of the symbols. Okay, these are the four symbols here. Okay, in this 4 cross 4 array, you have 4 symbols. First step is you need to find the probabilities of these symbols. Okay, you might have known how to calculate the probability. Okay, symbol 1. Okay, S1 is your symbol 1, and what is the probability of this symbol? It is 3 by 16, right? 3 by 16. And what's the probability of S2? It's 2, 4, 6, 8. Okay, 8 by 16.5. And what's the probability of S3? It is 2 by 16. What's the probability of S4? It's 3 by 16, right? You need to, first step is you need to find the probabilities of those symbols. In this slide, it's shown like S1, S2, S3, S4. These are your 4 symbols, and these are your probabilities. That means the symbol S1 is occurring 3 times out of 16. Okay, S2 is occurring 8 times out of 16. S3 is occurring 2 times out of 16. S4 is occurring 3 times out of 16. Okay, first you will find the probabilities. The next step is you arrange the symbols according to their probabilities, the in such a manner that the highest probable symbol comes first and the lowest probable symbol comes at last. Okay, first you will find the probabilities of those symbols. Next, you will arrange those probabilities in such a way those symbols in such a way that the symbol with the highest probability, that is S2, comes first, and the symbol with the lowest probability comes at last. That means in the descending order. Okay, and the next step is performing the source reduction till you get only two symbols. Okay, performing the source reduction until you get only two symbols. Okay, I'll show you how to perform the source reduction. Okay, you have arranged the symbols according to their probabilities and the descending order. Okay, S2 is the most probable symbol, S3 is the least probable symbol. Sorry. Now what you'll do is you combine the symbols with the lowest probability. You combine two symbols with the lowest probability to form a compound symbol. Okay, S1 and S3 are the symbols with the least probable, with the least probability, right? Okay, these two symbols are combined to form a compound symbol. Okay, that compound symbol has a probability of 0.3125, that is addition of 0.1875 and 0.125. Okay, and this new set of probabilities value will get, instead of 4 you'll get 3 now, because you have combined these two. This 0.3125 you should not write below 0.1875, because you need to arrange this new set of probabilities also in the descending order. Okay, so I have written 0.3125 here instead of here. Okay, this should also be arranged in the descending order. And now you should repeat this step until you get only two symbols, two values. Okay, here you have three values, right? You need to reduce it to two values. So this is 0.3125, 0.1875. Okay, these are the least probable symbols now. Now you combine these two to form a compound symbol again, and that has a probability of zero point 0.5. That is addition of these two, 0.3125 and 0.1875. You get zero point 0.5. You stop this source reduction when you get only two probabilities. Okay, only when you get two probabilities. Next you perform the encoding. Okay, I'll show you how to perform the encoding. Okay, here after performing the source reduction until you get only two probabilities, you start encoding. Okay, you, after source reduction you have only two probabilities, zero point 0.5 and zero point 0.5. These are equal this is nothing but an equal probability, right? You can assign 1 to this symbol and 0 to this symbol, or 0 to this symbol or 1 to this symbol. You can do it in any way, okay? 1 0 or 0 1, both are fine. Okay, I have assigned 1 to this symbol and 0 to this symbol. Okay, and we go backwards when we are assigning the codes. Okay, this zero point 0.5, it is a compound, it is a probability of the compound symbol, and this compound symbol is a combination of this 0.3125 and 0.1875. Okay, this is coming from these two, right? So you have to assign this 0 0 to both these values, and to differentiate between this and this you assign 1 for 0.3125 and 0 for 0.1875. And now again, this 0.3125 is a probability of the compound symbol, which is um, coming from these two symbols. Okay, you're adding these two probability and getting 0.3125, right? So 0 1 should be assigned to both 0.1875 and 0.125. And now to differentiate between this and this, you assign 1 for 0.1875 and 0 for 0.125. And this 0.1875 is not changing, it is going here same 0 0, and here also it's same 0.51 1 and 1. Okay, now for all symbols you have the code. Okay, for symbol S2 the code is 1, for symbol S4 the code is 0 0, and the symbol S1 it is 0 1 1, for S3 it is 0 1 0. Okay, now you have the Huffman code for all the symbols. See here, instead of using 8 bits, we are just using how many bits? Just 3 bits. 3 is the highest. You are assigning only 1 bit for S2, the symbol which is occurring more frequently. That means we are achieving the lossless compression here. Okay, and next I'll tell you some of the important properties of this Huffman code. Okay, this Huffman code is called as an instantaneous uniquely decodable block code. Okay, this is called block code because you're assigning the string of ones and zeros for each symbols. Okay, that is nothing but a block, so it is called as a block code. And this is called an instantaneous code. Okay, this is called as an instantaneous uniquely decodable code. Why this is called instantaneous uniquely decodable code is no code word is a prefix of other code word. See here, this is your 1. Okay, 1 is not a prefix of any other code. 011 is not a prefix of any other code word. Okay, there is no ambiguity when you are decoding. Okay, there will be no ambiguity in decoding. Okay, there is no need to put limiters from the code of one symbol to the code of another symbol. Okay, that means there is no need to use the limiters when you're coding the symbols. You can just code it as it is, just write the code word for that symbol, and it can be decoded in only one way because no code word is a prefix of another code word. Okay, these are all the properties of the Huffman code. Okay, in my next video I'll be explaining how to perform the Huffman coding in MATLAB. Okay, hope you have understood what Hoffman coding is. Thanks for watching.